So for example 1, we're going to do some polynomial division. Eventually we're going to factor polynomials, so knowing how to divide will help us break things apart. Before I do this example, the algorithm is almost identical to if you were to say divide 5 into, 141, where if you're dividing by 5, it goes on the outside, the 141 goes underneath the division symbol, and you just sort of walk through it. You'd say, well, 5 can't go into 0, but it can go into 14. You then choose a number as close to 14 as you can. So I'll do, 2 times 5 gives me 10. And then the number we get here, we subtract, leaving us with 41. And then we just repeat this process. In fact, we're at our last place value. We can go no further. 8 goes into 41 a total of 8 times. That's the closest I can get. So I'll put an 8 at the very top. 8 times 5 is 40. And again, we take the difference and we get 1. And we're done. 5 goes into 141 28 times, but there is 1 left over. The fact that this was not 0 means that 5 does not factor 141. Anytime that you get a remainder of 0, it means you factored the number 141 in this example. So if you want to be really explicit about what this means that 141, it's equal to 5 times 28, provided that you just add 1 more after it. So I want to duplicate this process, but I want to do it with 6x cubed plus 17x squared minus 3x minus 20, but we're going to divide it by x minus 1. And we're going to set it up almost identically to this process here, where outside of my division, I put the x minus 1, and inside I put 6x cubed plus 17x squared minus 3x minus 20. And I work through it in the exact same way. But it's different here because you have to use some rules of exponents. So let's see what that looks like. I want to get as close to 6x cubed as possible, but I'm multiplying by an x minus 1. So if I multiply this x by 6x squared, it'll give me a 6x cubed. So let's do that. Above the x squareds, I'm going to put 6x squared. And when I multiply 6x squared to x minus 1, I get 6x cubed minus 6x squared. Now, just like in the algorithm we did over here, we did 2 times 5 was 10, but we subtract that thing that we're putting here. So we're actually subtracting this whole thing. So you just got to be careful, because we're doing 6x cubed minus 6x cubed. That's great. We get 0. You don't even need to write the 0 if you don't want to. The second thing that we have is 17x squared. Now we get this minus a minus, so we're actually adding in this case. So it's going to be 17 plus 6. So that gives us a 23x squared. I then bring down the next number, which is a minus 3x, and I continue this process. Okay, so I now want to get as close to 23x squared as possible by multiplying by this x minus 1. So it'll have to be 23x, and I'll place that above the x's. Okay, so we get 23x squared minus 23x. But again, just being careful, I'm subtracting all this stuff, meaning I have 23x squared minus 23x squared, which is 0, but I have negative 3x plus 23x, which gives me an answer of just 20x, and I bring down the 20. So again, just to be clear, I did a minus 3x, then we had this minus a minus, which changed into a positive. That's 20x minus 23x minus 3x. Okay, we're at our last place value. This is our last step. I want to get a 20x by multiplying to x. Well, it's just going to be 20. It gives me 20x, well, minus 20, which is perfect. These two things are identical. If I subtract them, I actually get a remainder of 0. This means that x minus 1 factors 6x cubed plus 17x minus 3x minus 20. So this is why polynomial division might be useful for us in this class. It's because if you take x minus 1 and you multiply it to 6x squared plus 23x plus 20, that perfectly factors the equation we started with because there's no remainder. So just as a another example using the same function, 6x cubed and so on, I want to try dividing by x plus 2 to see if we get another remainder of 0. If we don't, it means that x plus 2 is not a factor of the original function. So let's set it up and try it out. That is x plus 2 divided into 6x cubed plus 17x squared minus 3x minus 20. So I'll start much the same way. Maybe we'll go a little bit faster this time. It still is going to be 6x squared, giving me a 6x cubed plus 12x squared. And I'm subtracting all of this, which leaves me with a 5x squared, and I bring down the 3x. Okay, now I want to get a 5x squared, so okay, I have to multiply by plus 5x. I get 5x squared plus 10x. And again, I'm taking the difference of this, so I get negative 3x minus 10x is negative 13x, and I bring down the 20. And okay, I gotta cancel the x's, so I'm gonna multiply by a negative 13. So I get negative 13x minus 26. And this time when I subtract, I get 20 plus 26. Okay, I have a remainder of 6 left over. All this work, what it means is you cannot factor. You can't factor x plus 2 out of the original function. But you can factor out an x minus 1, and again, the reason for that is we got a remainder of 0 in our first division, and we got a remainder of 6 in the second one. Okay, so for example 2, same idea, but I'm going to divide by a polynomial of higher degree. This one is degree 4, and also the thing I'm dividing by, the 7x plus 4, I think it's going to be harder to come up with some of the numbers just because there's not a 1 in front of the x, but let's see what we come up with. Maybe this won't be so bad. Again, I'm going to use the same procedure as last time. Okay, so I want to get a 7x to the 4th, so I'm really looking at this 7x. This time, I only need to multiply by an x cubed, a 1x cubed, which I'm going to put right here. So I'll make my decision. I think it's 1x cubed, or just simply x cubed. I'll multiply that by 7x plus 4. I get 7x to the 4th plus 4x cubed. Okay, so taking the difference, I have negative 35x cubed, and I'll bring down the 55x squared. Okay, so this time I want to multiply by, okay, it's going to be a negative 5, and it'll be x squared. So I get negative 35x cubed minus 20x squared. Again, I'll take the difference. So I'll focus on, again, that's that negative 55 plus 20, giving me a negative 35x squared, and I'll bring down the 155. Okay, I have to multiply again by a negative 5x this time. Okay, so I get negative 35x squared minus 20x. And I'm subtracting this. So let's see, that's 155 plus 20, which is 175x. Bring down the 100. And I'm at my last step. Okay, I have to do a little thinking on this one here. So, okay, what do I multiply 7 by to get that 175? And let's double check this here. That I think it's 25. So I think this is going to work out perfectly for this example where 25 times 7x is 175x, and then 25 times 4, okay, that gives me 100. Those two are identical, so when I subtract them, I get a remainder of 0. So what this means is, if you take 7x plus 4, and you multiply it to x cubed, minus 5x squared, minus 5x plus 25, that's the same thing as the original function that we started with. We're actually breaking it apart. So again, that's what polynomial division does. It'll take something and split it into a product of its factors. And for our last example, we're dividing x to the fourth minus 1 by, we'll start with first x minus 1. Now, if you'll notice in x to the fourth, there's no x cubed, x squared, or x term in there at all. And just like having a 0 in a number representing a place value, I want to actually put these in here. I want to put plus 0x cubed, plus 0x squared, plus 0x minus 1. It might not seem necessary at first, but having these as a reference point will be good for whatever we decide to multiply x minus 1 by. Here's what I mean. We first want to cancel an x to the fourth. I know I have to multiply this by an x cubed. This is why I want to put this x cubed spot in here, so I have some place to write the x cubes that I'm using. I don't think it'll be too difficult for this problem, but it's going to be a 1x cubed. This gives me x to the fourth minus x cubed. And when I subtract, okay, I get a 0 plus 1x cubed, so I get just x cubed. And if you want, you can bring down the 0x squared. I don't think this will be too hard. Okay, the next one's going to be plus a 1x squared, which gives me my x cubed minus x squared. And then when I take the difference, I now get a positive x squared, and I'll bring down the 0x. Okay, I'll now put a plus 1x, which gives me x squared minus x. Taking the difference gives me an x minus 1, and what do you know? If I put plus 1 at the very end, you get x minus 1, and taking the difference gives me a remainder of 0. And that's it. So x minus 1 divides x to the fourth minus 1. I wanted to do this example to indicate that if you are missing powers of x, you should definitely include them by putting a 0 coefficient. And the other thing with this example is you don't just have to divide by, an x minus 1 or an x to the first power times something. You can divide by anything more complicated than that. So I want to see what that looks like. It's a really similar process. That is, if I divide x squared minus 1 into x to the fourth plus 0x cubed plus 0x squared plus 0x minus 1, can I still do this even though it's now a power of 2 instead of power of 1? And as long as you're comfortable with your rules of exponents, you certainly can. So what I'm going to do is ask myself, all right, if I want to get an x to the fourth, and here I have an x squared, what do I multiply it by to get x to the fourth? And this time the answer is an x squared. You get x to the fourth, but you get minus x squared, so that when you take the difference, you have an x squared. And maybe I'll just leave it at that. You could bring down the plus 0x. I guess there's nothing wrong with writing that down. But now the question is, okay, if you want to get an x squared, what do you multiply this by? Oh, it's just going to be 1. So that's going to go all the way at the very end, plus 1, which gives me x squared. We don't actually get any x's, but we get this minus 1, which means we'll actually have to bring down this number at the end. When we take the difference of these two things, everything completely cancels. This means that x to the fourth minus 1 is actually the product of x squared minus 1 times x squared plus 1. I put this example in here to indicate that there's flexibility when you're using this algorithm. You don't just have to do something like x to the first plus or minus a number. You can divide by an x squared or an x cubed or whatever. Just kind of like try it out and see what happens.